Hi everyone. So uh, today we'll be diving a little bit into how the development strategy for a agentic system would look like. So being myself a engineer, I kind of debate across how the development and CI/CD setup should look like for a agentic engineering setup. So the major problem is that in traditional systems, the outputs are deterministic, and it's quite rare when we have any system which has an probabilistic model. But the LLMs are probabilistic, and the outputs are uh, probabilistic. They are not deterministic models. So this is where the whole problem comes in. So it's hard to know what it gave. It's hard to reason why it gave it. It's hard to reason what we should do to improve it if we don't have a clear development guideline and uh, for the development. So today I'll be going across the Langfuse Academy. So it's Langfuse is a open source tracer, I would say, or more than a tracer. So it's like uh, you can so it gives you full authority like of your agentic systems. So I'll walk. So this is pretty interesting. This is pretty basic and pretty interesting. So in coming days, we'll be diving deep into each of the topics. I think every topic carries its own weight. So for today, we'll go through like uh, the key development methodology that they suggest, and let's think and reason whether it will work or not. So coming to the development strategy. So uh, let's ask a simple question. So what's an agent? So my definition of an agent is it's a it's a black box which does which does certain calls to uh, do a task X. So input task X, uh, we send it to an agent, and agent is responsible for solving the task X. So how we do it is from an outsider, from a user perspective, it's black box, and it's like compared to the standard systems, agents are not meant to be deterministic. They're not meant to take a same route every time. They are supposed to be branched, and every time they are supposed to take a different route. So that's what makes it different from the traditional software. And here, how we manage the behavior of the agent, uh, how we make sure that each task X or Y or Z gives its correct output without failure in production. So that's the goal here. So how can we make sure that we are on point, that we can deliver the correct results, and how confident are we on that? So yeah, so to do any of this, we need the logs. We need to know what the system is. So we need a detailed ano- uh, anatomy of what's going under the hood. So that's where the traces come in. So a trace is, let's say, if you ask a trace is by definition, it's a log. But in this definition of agents, a trace here, let's it's better to define as a sequence of events occurred when we call a event X. So what is the sequence of steps that the agent did? So clearly logging it becomes the trace. So yeah, that's the first part. So this is the pi level architecture that they are suggesting. So that's what iterate is. What's monitor? It's of no use if we don't use our data. So traces are raw. You can't do anything with raw data unless you have your KPIs, you have your definitions set, and you have to get the best out of traces, and you have to look at traces which are important. So you can't look at the whole bunch of raw data and say, okay, I'm going to do something with it. It's not humanly possible. It's not even feasible for a AI or any system to do it because it's waste of time. You have to focus on traces which are important. You have to focus on things that matter. So monitoring is basically surfacing the traces which matter and showcasing how you tracking, showcasing and dashboarding the KPIs that matter. So this comes on a after deployment basis. So what if we find issue in trace from a trace or but from a monitor? Like let's say the issue can be if the system itself is not behaving properly, or the problem can be the system is not meeting certain KPIs which are not. It's not a system's fault. Let's say we design a system we without the cost of the latency in mind. Now the agentic system is able to do the task, but it's not meeting the KPIs that matter. So we need to test all these uh, things before. So we are familiar with data sets. It's common practice that we maintain a data set, and it becomes a whole new challenge of building data sets for agents because they the development methodology is different. So if we look back and look at like 5 years back, we had the training data set for the ML model. We know what the model was trained on. We know what the model can answer. With the case of agents, it's totally different. We don't know what like the LLM is trained on. We don't know what's the behavior that we are going to get out of it. And we don't know what the agent, even the agency system is going to behave because if it's an open-ended agent, it can do anything. So grounding it is important for for giving uh, for giving any customer that this is going to work on this and to get the internal confidence or to get the customer's confidence, it's really important for us to make a baseline. And we can't look uh, anywhere other than building a data set and making it clear, okay, this is what I'm expecting and this is what we should get. But the process, I think it's different. I'm still exploring the area. But yeah, so if we find a problem, we have to log it into our data set and we have to test it thoroughly before deployment if it's a major change or like there are some changes like we want to like change maybe the tone of the request, like the tone of the output. For those things we don't need the data set. Like if we can if it's a like a simple prompt change, we can go ahead and do the prompt change. But to certify the core system itself, we need the data set. So the other two things are experiment and evaluate. So what's an experiment? So unlike again like traditional software, here the agents is a collection of non-deterministic paths. We have a RAG system which is non-deterministic. I mean, the process is deterministic. If you take it's only a vector, if it's only a vector RAG, it's deterministic. If it's a hybrid RAG, it's not. It's a non-deterministic. If it's a graph RAG, it's non-deterministic. So retrieval itself is a non-deterministic piece, and on top of that, we have the LLM generation. We have other pieces moving around, which are like not non-deterministic process. So to pinpoint even what to optimize, where to optimize, and how to show the value of the optimization, we really need a experiment setup which can separate and make sure we get fruitful results out of each experiment rather than a colossal experiment with the colossal experiment might help, but we won't be knowing what's the change, what we should focus on in going further. Is we don't know whether to like improve the retrieval or whether to improve the LLM, like whether to switch the model. or anything else. So it's really important to segregate the experiments and run them in a secure setup. So the last piece is evaluate, which is kind of, I would say, again, like data sets, it's also the open field. So judging an LLM's answer is not so trivial. So if by the industry standard, if we go by LLM as a judge, the industry itself states that like the judge model itself is biased. It's a probabilistic model. So we have to even experiment and evaluate pipeline itself. So if we there is no way we can humanly go through all the uh, generations of an agent if it's a high throughput agent. If it's a low throughput agent, yes, human in the loop is the best eval out there. So we'll just let's just have a manual review and have it shipped. If it's a high throughput agent and it's a open-ended agent, it's really hard for a human to do it, and the only op chance there is to go through a LLM as a judge, but LLM judge itself is an ocean, and we'll be diving deep into it in coming days. So yeah, these are the five main pieces. I'll walk you through their individual blocks. So when we come to trace, so by definition, a trace can be as complex as simple request to your applications. So it's a yeah. So one thing I forgot to mention is a trace will have observations. So without observations, that like so it's important to even have a level deeper than trace. So as we discussed, a trace is a let's say track of a high level user, like a high level request. So if I'm asking ChatGPT hi, the trace like the log generator for that particular thing is a trace. But there are other things going under the hood. There is network calls going, there is retrieval going. So each of them are repeating paths in loop for every request. So all these are observations. So let's say I have a customer support agent, where I went and asked the status of my ticket on Wi-Fi. So first it will fetch my like if first I send it, the request will go over the network. It will fetch my then the agent will fetch my uh, personal credentials. Then it will fetch its from its knowledge bank. So it became retrieval. The first part is networking retrieval. Then it will maybe send it to a LLM and ask to generate a uh, response based on my current status in the DB. So it's a three-step process, and every time it's kind of repeating, and these actions are repeating. So the network action is repeating everywhere. The retrieval action is repeating everywhere. So these are like clear observations. So each trace will have its own set of observations, and it makes it easier to follow through a trace. And we can like a session again by session definition they mean collection of traces, and drawing the line between when to call it a trace and session, it completely depends on the use case and the project requirement and the level of observations we have. And that's like a experiment in itself, and but keeping these three things will give us a pretty uh, broad source for our running agent. So yeah, session is a collection of traces. Traces are a collection of observations. Observations are basically the smallest unit of work that the agent is doing, like each tool call and each system call that's it's doing. So that's about the trace. So monitoring, as we discussed, it's uh, it's actually getting insights from the traces that we have. Uh, so monitoring, there are so one thing that monitoring has that uh, there are so this is a very interesting metric that these guys have mentioned. So aggregated metrics and signal detection. So we have traces, we have the observations. So from the observations, we will aggregate the certain metric that we're looking for and we'll show it. And signal detection is kind of interesting here. So as they said, there are two types of feedbacks. So a signal is uh, a feedback on the system, and there are two types of feedbacks that the system can get. Either it can be an explicit feedback that the application of the agent itself is asked after its work, or it's an implicit feedback. Uh, I think it's a very studied topic to uh, have the systems get better with implicit feedback. So I think one thing that comes the top of my mind is the ads that are going on right now. So the ad industry is pretty big and it's pretty good. It's we get pretty accurate ad recommendations for most of the use cases, and we don't mention them explicitly anywhere. I want this product X to come on my feed. How is it even being done? It's from the implicit feedback the system is taking. So the system itself is collecting some background events. From that, it's processing and giving us the ads that we want. Same thing follows here. The explicit feedback is something that they like in ChatGPT after the end it's ask for a thumbs up or something. It's and we give it thumbs up or not. And this explicit feedback is like really skewed. The data can be skewed, but the implicit feedback kind of tells more than what the system can tell. So what can be the examples of implicit feedback? Let's say uh, copying the code and the decision or uh, accepting some suggestions in a code editor. The like it's these are actions that the user is taking after the agent's output, and these actions carry a lot of weight. These say this clearly gives us a positive or negative direction in in the system. So coming to data set, yeah. So on a high level, the data should have three things: the expected input to the agent, the expected output to the agent, and the metadata. So why metadata here is one of the topics that I wanted to explore. As we discussed, it's like the failure is not on the input output observation, it's inside the system, how the traces behaved, how the each component behaved, and we to solve a like a accuracy issue on the agent, we need to go deeper into like the data set itself, and a input output data set wouldn't work because it's not an ML model that we will nudge the model to do certain task X. We need like the individual traces to know where to even fix. And my argument is that like the data set should have the expected tool call behavior, the expected um, networks simulation behavior, and everything. So that's one of the changes that I expect from the dataset creation part. And coming to experiment, so here each experiment will be separated, and it's pretty important to separate the experiments. It's like so whatever variables we have and the variables we are testing on, it's important to test individually each variable and see which one carries weight so that we don't mix, chop, and change there. So we have a baseline which is running. We create a data set. We have the experiment on all the possible combinations that we have from the variables that we have, like the uh, non-deterministic boxes we have, like retrieval, like the model, like the prompt. Everything is a non-deterministic process. Like changing everything will make the agent behave something separately. So, yeah, coming to the experiment evaluation part, I think it's again the open thing. It's the if the change is simple, if the change can be eyeballed pretty accurately, a data set is not like a LLM is not needed, and it's always best to have the human evals being done, and if it can be done by humans, the human in the loop is the best. But if the system's throughput is so high that it's not humanly possible to do, we have to use a uh, we have to use a LLM as a judge, and LLM as a judge comes with its own skewing, and it's really important to tune the LLM as judge, or else we'll be judging the outputs with something which the judge itself is not good. If the judge itself is not good, it doesn't make it won't make any sense to even like run a evaluation on it. So yeah, those are the ideas that I want to keep in my mind to follow how I should be building an AI system. I think these are like the foundation uh, thinking or towards the AI development cycles and the agentic development loops. And yeah, in upcoming sessions, maybe we'll discuss more on the individualities.